So we're going to solve an application problem in the form of a quadratic. And sometimes application problems are scary. Sometimes. But once you are able to break it down, it makes it so much easier. So here we have a model rocket, and it's launched with an initial velocity of 100 feet per second. And from the top of the hill. So this is telling us that if I was to draw this out, I have a hill like this, right? And it's saying at the top of this hill right here, I have this rocket. And it's going to be launched. Okay? And it's going to hit the ground somewhere, out somewhere. Anyways, so it said that it's going to be launched at a velocity, at a speed of 100 feet per second. And then it said that this hill is 20 feet tall. So if I was to measure it, it would be 20 feet. Okay? And it says its height is in feet, t seconds after it has been launched. We get this function. Okay? And it says determine the time at which the rocket reaches the maximum height and the maximum height again. And the thing here is the wording is a little off. We're wanting to know the maximum height and the maximum time that it got that height. So we're basically looking for an order pair. So I got this straight out of the book, and I apologize, the wording is kind of not as clear. But what it's basically saying is we want to know how many seconds that it reached the maximum height. So what we want to know is that we know this is a parabola, right? Because it's a quadratic. We want to know when this actually reached the maximum height and how long it took to reach that maximum height. Well, you were given everything you need to know. We already have this written in the quadratic form. It's already written in ax squared plus or minus bx plus or minus c. Well, in this case, t is going to be x because we're talking about time. And we're going to say this right here is my x-axis, and it represents time, so it's going to be t. So let's solve for it. Well, in order to solve for it, we need to use the vertex formula to find that one, where it's h comma k, where h is negative b divided by 2a. Well, we got negative, and our b is 100. That's divided by 2 times a, where a is negative 16. Well, negative divides negative is positive, so I got 100, and then 2 times 16 is 32. And, of course, we're going to reduce this. You always reduce. You don't want to leave it in some unsimplified form, so we always reduce it. And let's go ahead. Well, once we reduce it, we're going to have a fraction of 25/8. But, you know, most people won't know what's 25/8 seconds, right? So we're going to actually convert this to decimal, and I keep wanting to write 28 instead of 25. Let me fix this. 25/8. All right, there we go. Because this reduces by 4, right? 4 goes into 125 times, 4 goes into 32 8 times. But let's go ahead and round this. We get a decimal of 3.125, and I didn't have to round this. It actually went all the way out to that. So this is going to tell me how many seconds it reached that maximum height. So over here, I'm going to, and this here, like I said, I pulled it from the book. It should be time it took to get there. So far my order pair is 3.125. Now let's find how the maximum height is. Well, we have to go back to our equation, and we're going to have to plug in for t what we found. Bear with me on my writing. So now we found, so we're going to plug in 3.125 everywhere as I see T. All right, so now let's figure this out. So I know that we have 3.125 squared, which is 9.765625 is a long number. So I'm going to multiply that by the negative 16. Okay. That answer will be added to the 100 times that 3.125. And then we're going to add 20. So my answer is going to be 176.25. Be sure and read if it tells you to round or not. In these cases here, we actually got it. We don't have to round unless it's asked to round in the software or on my test. All right, so I know that this is my maximum height. That's how high. That's this point right here. It's where it reached its maximum height. So if I was to draw it, it should look something like that. And it took 3.125 seconds to reach it. And this is in feet. So since it is an application problem, you would make a statement. And you would state in 3.125 seconds, it took the rock, or hang on, let's reword that. See, I'm not an English person, so I'd have to write it twice. I would actually say it took the rocket 3.125 seconds to reach its maximum height of 176.25 feet. And that is how you solve this application problem. Thank you.